Module 4 Groundwater Exploration Session 2. Dear students, in this session, we'll be studying about electrical resistivity method using Venner's configuration. Electrical resistivity method. In this method, it depends on differences in the electrical resistance of different soil and rock types. The flow of current through a soil is mainly due to electrolytic action and therefore depends on the concentration of dissolved salt in the pores. The mineral particles of soil are poor conductors of current. The resistivity of soil therefore decreases as both water content and concentration of salts increases. So the resistivity basically is a property possessed by all materials. The electrical resistivity method is based on the fact that in soil and rock materials, the resistivity values differ sufficiently to permit that property to be used for identification. To determine the resistivity at a site, electrical currents are induced into the ground through the use of electrodes. Soil resistivity can then be measured by determining the change in electrical potential between known horizontal distances within the electric field created by the current electrodes. This whole setup it is called as Venner's arrangement or configuration. In this, it consists of four electrodes, that is, two outer electrodes, two inner electrodes. The outer electrodes are connected with battery milliammeter, whereas two inner electrodes are connected with voltmeter to measure the potential drop when the current is induced in between the electrodes. So in this setup, the electrodes are placed at an equidistance. As you can see in this figure, it is shown as a distances between the electrodes. So the outer two electrodes are connected with a battery and an milliammeter. From the milliammeter, current is induced, whereas the inner two electrodes are connected with voltmeter that will be used to measure the potential drop. A direct voltage causing a current of 50 to 100 milliamperes typically is applied between the outer electrodes, and the potential drop is measured in between the inner two electrodes by a null point circuit that requires the flow of current. The resistivity of a material can be determined by the formula R is equal to 2 pi AE divided by I, where A is the equidistance between the electrodes, where E is the potential drop in volts, I is the current passed or induced in between the electrodes measured in amperes, where R is the resistivity. So some of the resistivity values for different materials can be seen in this table. Clay and saturated silt, its resistivity in between 0 to 10. Sandy clay and wet silty sand 10 to 25. Clayey sand and saturated sand resistivity value is in between 25 to 50. Sand 50 to 150. Gravel 150 to 500. Weathered rock 100 to 200. Sound rock 150 to 4000. Dear students, you can see that the resistivity values for different kinds of materials is having the value changes. So in this session, you are able to learn the electrical resistivity method using Venner's configuration and the values for different types of materials and their resistivities. Thank you.